Making Your Own Natural Soap 101. You can hardly go to any farmer's market or craft fair today without seeing someone selling their own homemade soap. Why would anyone want to go to all that trouble? The soaps you buy in the drugstore are commercially made. In their processing, the glycerin produced naturally in soap making is removed and synthetic ingredients are substituted. They use the glycerin in the higher-priced lotions. Some of these soaps contain high amounts of animal fat, chemicals, petroleum, artificial fragrances, and detergents. Homemade soap, on the other hand, uses simpler, natural ingredients like vegetable oils instead of animal fat and less chemicals. Most importantly, glycerin, a natural cleanser and moisturizer, remains a part of these soaps. These soaps are considered more gentle to the skin. Soap making is much easier than I thought it was going to be. I used what soap makers call the melt and pour process, which is designed to be quicker and easier for beginning soap makers. In this method, the soap base is created for you, but it's in this process that all the real chemistry takes place. So after we get everything set up, I'll explain how the soap base was made. First, gather all the necessary equipment. Soap base, the ones I'm using are a plain white and a goat's milk. Knife to cut the base. Pyrex measuring cup, I'm using a 2-cup one. Long-handled metal spoon. 3 milliliter measuring cup, like one used for medicine dosages. Coloring, scent from fragrance oils. Soap molds, I have both small and large ones. And plastic wrap. I'm using 2 types of soap bases. One is plain white. This melt and pour base is an odor-free glycerin soap made with 100% vegetable oil, coconut actually. According to the manufacturer, it contains no alcohol or products that will dry the skin. The other is goat's milk, which is also an all-vegetable glycerin base with goat's milk added for extra moisturizing. Both bases maintain a neutral pH of 7.8, contain no animal oils or artificial colors, and are totally biodegradable. I'm working with both small and large soap molds. The small mold looks like a candy-making mold. You could even use an ice cube tray if you wanted to. This mold happens to make small round snowflake soaps. My large molds make large snowflakes or holly and ivy soaps. The large mold comes in 2 pieces. You put them both together and rubber band them to hold it shut. Make sure once it's together that there is a pour hole at one end and that the other end is completely closed, because you will be pouring your soap into the mold. For coloring, since I'm making Christmas gifts, I have emerald green and Santa red. For scents, also keeping with the holiday theme, I have frankincense, Christmas Eve, and sleigh ride. Most experienced soap makers use a cold process, which allows them to create their own soap bases. These bases are at the heart of the soap making chemistry. Looking at soap making in simple terms, it is the result of a chemical reaction between an acid and a base to form a salt. This process is known as saponification. In cold processes, soap making, an acid, like coconut oil, is mixed with a base, lye, to form soap, which is a salt. Common acids or fatty acids used in home soap making are coconut oil, olive oil, and avocado oil. Commercial soaps use tallow. which is fat from animals like cows or sheep. Each of these acids is part of a triglyceride, which is a compound made up of a glycerol backbone with one fatty acid bonded to each of its 3 carbons. These bonds are called ester linkages. It is the fatty acids that determine the characteristics of the soap. They can make a soap that has a creamy or bubbly lather, that is a conditioner, or a cleanser that is a soft or a hard bar. For example, lauric acid makes a hard bar, but if you use too much, it can dry the skin, and linoleic acid acts as a conditioner or moisturizer. But too much of it, and your soap will turn rancid. Soap makers have to learn the art of managing this chemical reaction by the combinations and amounts of acids they use. In soap making, the process of combining the fats or acids and the lye or base results in saponification, which is the base alkaline hydrolysis of the fatty acids. When saponification occurs, the ester linkages between fatty acids and the glycerol backbone in a triglyceride is broken to form a glycerol and soap. When the base and the acid combine, the triglycerides release the glycerol molecule. It turns into glycerin. The fatty acids can then combine with the hydroxide ions to form the soap. The glycerin is called a hygroscopic because it attracts water from the air, making it a great moisturizer. This is why commercial soap manufacturers separate glycerin from soap for use in expensive lotions. Drawn out, the chemical reaction looked like this. Soaps can dissolve in water, and they can also dissolve oils and grease and help water to rinse them away. The soap molecules are actually attaching to the molecules of the grease and to the molecules of the water. Therefore, they all just float away together like the soluble dirt. Start with a base, either goat's milk or white. For this demo, I'll use the white base. Cut the 2.2 pound brick of base and use 1/4 of it. Cut the piece of base into small pieces and place in a 2-cup Pyrex measuring cup. 3 milliliters of scent. Put the cup in a 1100 watt microwave and heat the base for 30 seconds at full power. Take it out of the microwave and stir it with long-handled spoon. Return the cup to the microwave and heat for another 30 seconds at full power. Take it out of the microwave and stir it with long-handled spoon again. Quickly add a couple drops of color. Use the amount you need to get the intensity of color you want to melted base. And quickly stir into melted base. Immediately pour the soap into molds. Let cool and harden for 10 minutes on table. Cover exposed portion of soap with plastic wrap and put in the refrigerator for half an hour. Take molds out of the refrigerator and pop soap out of mold
and onto the plastic wrap.
and onto plastic wrap. Cover each soap completely with plastic wrap as soon as the bar is cool. As the soap bases contain water as part of their formula, if they are left out in the air, water will evaporate from the bar and it will shrink. Let it dry for 2 to 3 days to completely harden. Give as gifts or use yourself. Happy holidays.